doesn't show it sometimes. I don't know. It's really annoying. Ooh. Okay, here we go. Okay, you ready, group three? All right, good. Okay, so here's the problem with this last one, and then we're gonna walk around the room. Half of you are gonna walk around the room, the other half are gonna do a Big Ten, and then switch. So, but I have to finish the notes, and I think this works out okay. That we could really focus on this really, 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 really bad one. All right, and I meant to tape myself last hour, but I forgot. And I might do this different because I kind of started working on the x-axis with these values and then wrote some values down, shifted it, then I had to erase and then rewrite, and that's just a pain. And some bums use a pen on math tests, and that's not going to work with graphing. So whatever that bum is in this classroom, you better invest in a pencil. Hold up, what are you holding right there? What is that? Is that a pen? Someone smacked that pen out of his hand. No violence. Don't do that. That was just a joke. Internet, don't call the police. Watch what we say. By the way, is it true a camera adds 15 pounds? Man. Or is it just my eating habits? Anyway. So 0 to 2 pi. Half of 2 pi is pi. Half of pi is pi over 2. 1 pi over 2, 2 pi over 2, 3 pi over 2. I'm going to do this different. This is what I used to do all the time with graphing with right-left shifts anyway. This is what we would have marked on the x-axis, right? If it was not phase shifted. And that's the problem. We know that's the big worry. And then what kind of phase shift is this? We kept it easy, no factoring. We just got to tackle this right pi over 3 thing. I'm going to tell you why I'm doing this off to the side, because I was messy last hour, and I'm glad I didn't video it because it probably made me do longer on this. So what would normally happen, it's okay to do this because we're not too far right pi over 3. Remember yesterday, do not forget when your phase shift is large, really try to see, is it bigger than a period? And then you could subtract a period out, and then that's really the smaller phase shift. That's true. We had stupid questions in our old book when the phase shift equaled the period. Let's think about that real quick. If the phase shift equal the period, what really happens? It starts with an N. Nothing. Because all you're doing is cutting and pasting the graph over here, and then the one that was over here just pastes right on top of the one that just left. Right? So now we have to think about that. That's good to cover that again after a night of doing your work. Maybe this makes a little bit more sense on example 2. We could have reduced that down to a phase shift of pi over 3 and started with this graph. And it ended up happening anyway. Okay, but what we got here is not that. Wrong. We do have a phase shift that's smaller. The problem is it doesn't match any of these fractional parts. Are you listening? You're not watching because you're doing this right now. Are you crying during the notes? What is this? All right, let's go. Pay attention. All right, got to watch everyone. Are your earbuds out? Okay, I'm just making sure. You don't have to, All right, now, how do I add pi over 3? Well, that's easy. I could add pi over 3 to this, right? No problem. All right, but then here's what the kicker is. You're not going to like this. And then I'll tell you how I marked some people wrong with the red pen of justice on y-axis scaling. I had bums do this. We're going to be okay to do this. Don't write this down next. We're talking about all right, I guess I shouldn't call you bums. That's passive aggressive, Mr. Samuels. All right. When I think I can move this over a little bit. Can you guys do that? No. All right. But you don't have to. I had people do this. Oh, the amplitude's 3, so they put 3 here and -3 here, and then 4 and then 5. What's wrong with that? Is this 3 units and then is this 3 units? No, I marked a half point off for that. That's sloppiness. So why am I bringing that up? You cannot do the same thing with the x-axis. That is the hardest part of this problem. How do I deal with that? So now I'm a little worried because I'm going to start pi over 3. You don't just start pi over 3 here. No, and that's going to be wrong. So let's see what we have to do. How do I add pi over 3 to this? Well, what do I have to get? A common, anyone? common denominator. And then I'll figure out what the best spacing I could do is. So add pi over 3. So this one I'm going to have to multiply by 2, right? And this multiply by 3. And then what I end up getting is 5 pi over 6. So you do have to understand that these are pi over 2 away. Still, I just had to get a common denominator. Still a quarter of the period away from each other. And now, honestly, you could keep adding pi over 2. You really could. What you really could do is stop this right here. You could have done it right here and just kept adding pi over 2 to each of the next values. Okay? So, or I could add pi over 3 to pi. By the way, pi over 3 and pi is 3 pi over 3. This would be 4 pi over 3. And then add pi over 3 to this. This is back to the 6's because I have to multiply by 2. 6 pi plus 2 pi is 8 pi. Wait a minute. Did I screw something up here? Okay, 2. Oh, that's what I screwed up. This is multiplied by 3 to get a common. That's a grade school mistake. 9 pi plus 2 pi is 11 pi over 6. And then add pi over 3 to 2 pi. I don't know if this is the right way. I don't know what the others are doing. I guess I couldn't care less, right? 6 pi over 3 plus pi over 3 is 7 pi over 3. Whatever way you need to get that happens. But here's the thing. I need to go by over 6's. So so from 0, then I got to move this to, and I want to make sure I'm okay on this. So this is 1 pi over 6. This is 2 pi over 6. So this is where pi over 3 is. I can't put pi over 3 here because then the next one over here, if you go like that, you're going to screw up on the left side, and I'll show you that in a minute. This is going to be messed up, and your scaling will be off. So I think it worked out better last hour when I put it on the grid and then did our moves. So, yeah. But this is where our key value is, and then understand that that's pi over 6 right here. So I'm going to put that above here. This is a mandatory because watch what happens. Because then these all represent pi over 6. So this is 3 pi over 6 moved over, which is pi over 2. And that gets me the 5 pi over 6. Then add a pi over 6, add a pi over 6, add a pi over 6. That's another 3 pi over 6 added. And that's 4 pi over 3. What I want to do is just notice something that bothers me. I don't want that to be looking thick. I want the thick ones to be my starting point. I meant to do that too. Start. That's our starting point. That was easy. The first one's easy. 0 moved pi over 3 to the right. Yeah, I start at pi over 3. Here's the hard part. This. And then understanding that this is pi over 2. And then this is pi over 2. And then the fact of the scaling, I got to use 3 spots because the common denominator between 3 and 2 is 6. So I have to go by over 6's. And that was on your worksheet 2 days ago, wasn't it? Remember that? Having to work with common denominators to scale an unknown graph, to scale your axis. That's why the other two are geniuses on that as far as getting you ready. Wax on, say it. Okay, they refuse. All right, 1, 2, did I do this right? So 5 pi over 6, 4 pi over 3, 11 pi over 6. Oh, you know why? I'm throwing myself off because I'm counting the y-axis, and it doesn't. So it's 1, 2, 3. Ooh, I barely made it. 4. And that's 7 pi over 3. And I'll prove that's a starting point. I'm going to highlight these again, that is a distance of pi over 2. But I had to do pi over 6 notches, the common denominator between 3 and 2. Because watch. Now what I got to do is go left, and then here's the rub. 1, 2, 3. And then what are these a distance of? Pi over 6. So this is negative pi over 6. What I want you to understand is the y-axis doesn't even play. The y-axis is not a critical value. This is what I told you why this is the worst question. And then the other thing, remember the scaling about making this 3 for y right here and negative 3 and me marking that wrong? That's just as wrong to not have 2 spaces to the right for this one and only 1 space to the left, as that's correct, meaning you'd be wrong if you didn't have 2 spaces to get to pi over 3 and one space to get the negative pi over 6. The spacing. So now you understand why the other two teachers leave this blank. You know, you can move your y-axis wherever. You guys, I did a better job on this one. I started my y-axis way to the left because I had a big phase shift right. So that's the argument for that. I don't know. I might still, I like having the axes on the grid already because I just like everyone's graph to be in the same spot. But that's the argument for it. 1, 2, 3. All right. And then hopefully you can kind of toggle that these go between over 3s and over 6s. So I surmise that this would be, well, I'd actually have to add -3. So it's negative 4 pi over 6, which is negative 2 pi over 3. So then what am I adding as I go through here? 1, 2, 3. I'm adding pi over 2, or subtracting really, mathematically. So that's adding a -3 pi over 6. Or sorry, yeah, I guess I gotta. So I got to think about that as -4 pi over 6. So that's -7 pi over 6. That's kind of tough. Now this is all fractional work, and again, it is grade school, but again, people are fractionally challenged. And then it's going to be another over 3. You know what I could add is a pi to this one, and then that's -5 pi over 3. Because that's 2 periods away from this over 3. I was trying to think of a better and easier way to get, you know, these other values. So if this is pi over 2 to the left, this is pi to the left, all the way from -2 pi over 3. So I added -3 pi over 3 and got -5 pi over 3. But I do, that we're humans, we notice a pattern. It goes from over 6 to over 3, over 6 to over 3. You know what else I'm going to do just because I want to stay away from these values? You have all the power in the world. I'm going to make this 1. The only reason I'm doing that is I want to stay away from these values and not have to graph over them. So if I put 1 right after the 0, the scaling by 1, it would just be in the way and the graph would be smushed. You don't have to do that. Okay, some people, and I missed it on the quiz, they put their values down here for x. I guess that's okay. I'll look out for that in the future. Almost done. Hey, remember, this is where we start, though. So I should put, like, start, this is where. Drink time. How does this start? Oh, and who am I graphing, by the way? Who am I graphing? Secant. Who am I graphing? Cosine. What does cosine start as? High, middle, or low? Which one is it? Which one is it? Low. How low can we go? And then 0, and then high, and then 0. See? And then low. We do have to have that finished. And then some of you don't have to draw the dotted line anymore, right? Some of you should know right away that that's where the asymptote is. That's where the asymptote is. And then, see, this is not part of it. This is the next critical value. So 0 right here. The y-axis is skipped as a critical. There is a y-intercept. It's just not specific. It's not part of the critical value ideas. I had to double check. There was no phase or no up-down shift. I just wanted to check real quick. And then here's where your asymptote is. So that's what you're going to have to get these spaces correct. Just like the y-axis spaces. And then I don't think you have to graph it anymore. Shared and then flipped up. Because this is where the cosine graph is. Dun, 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 dun. You don't have to do that anymore if you get it. And then this is where that, did I say cosine? Wrong. I want to do that one again. Doink, doink, doink. Why is that not going back? Because there is a y-intercept. I just don't know where it's at. I could find it by plugging in 0 for f of x and solving. You don't know how to solve trig equations yet, though. So that will come in the future. By the way, input, say it. That was probably some of the worst parts of our quiz. Wait a minute. Did group 3 do anything? Were you guys on? Were you ready? Were you ready to answer a question? Sorry, Caitlin, I lied from yesterday. So we're going to be done. But we're going to walk around the room and do input, say it. Remember that part of the quiz? That might have been the worst part. And I will say this. You ready? On your quiz a week from today, I'll put this in the video. On your quiz a week from today, it's going to start with evaluations, but it's not just going to be what's the sine of 7 pi over 6. By the way, what is the sine of 7 pi over 6? Negative 1/2. Why? What's an over 6? What's the angle measure? 30. What's sine of a 30 always? A half. And then all you have to figure out is it negative or positive. Right? Okay. Okay, so anyway, it's not going to be that easy. It's going to be like what you had on the quiz again. 3 questions of evaluations, and that's what we're going to have up on the board, and we're going to do that next. And then another exercise. So we're going to have fun